A very good morning to our Encik Zulkifli bin Saji, our lecturer, and my dear friends. Today I am talking about the presentation of the power system, and then the title is the environmental impact of the transmission line. I am Dhanush Kumar as Manishilan, and then my register number is 25 DEE 21F2001. The first environmental impact of the transmission line is as aesthetics. Potential aesthetic impact is the overall aesthetic effect of a transmission line is likely to be negative to most people, especially where proposed lines would cross natural landscape and private properties. The new tall steel or wide head frame structures may seem out of proportion and not compatible with agricultural landscapes or residential neighborhoods. Landowners who have chosen to bury their electric distribution lines on their property may find transmission lines bordering their property particularly disruptive to scenic views. Some people, however, do not notice transmission line or do not find them objectionable from an aesthetic perspective. To some, the lines or other utilities may be viewed as part of the infrastructure necessary to sustain everyday life and activities. The first point of the aesthetic is the aesthetic impact depends on the physical relationship of the viewer and the transmission line. The second point is the activity of the viewer, and the third point is the contrast between the transmission structures and the surrounding environment, such as whether the line stand out or blends in. And then a transmission line can affect aesthetics by removing a resource such as clearing French cirrus, degrading the surrounding environment. And then last is the changing the context of the view shade. And then mitigation of the aesthetic impacts is the electrical transmission line may be routed to avoid areas considered scenic. Routes can be chosen that pass through commercial or industrial areas or along land use boundaries. Form, color or texture of the line can be modified or somewhat minimize aesthetic impacts. There are some choice available in transmission structure, color or construction material. Structures constructed of wood or of rust brown oxidized steel may blend better with wood landscapes. Stronger conductor can minimize line sag and provides a sleeker profile. Road management can also mitigate visual impact of transmission line. Some of these techniques include planting vegetative screen to block view of the line, leaving the road in a natural state, and road at road crossing, and placing and peeling brush from the clear road so that provide wildlife habitat. In the end, aesthetics are great extent based on individual perception. Seating design, construction materials, and road management can mitigate some of the adverse aesthetic effect of a line. It is in the interest of the applicant and the affected landowners to discuss the measure early in the planning and design process. Public comments made during the review process of the construction application can help decision makers understand local concern about the exciting landscape and potential aesthetic impacts. The second one is the electric and magnetic field EMF. Source of the field is electric and magnetic field EMF occur whenever or wherever electricity is used. Magnetic field is created when electric current flows throughout any line of wire, including the electrical wire in the home. Source of magnetic field include electrical appliances such as power tools, vacuum cleaners, microwaves, computers, electric blankets, fluorescence lights, and electric baseboard heat. Result of EMF research is the Since then, research, scientists have conducted many studies designed to determine whether or not exposure to EMF affect human health. Scientists have uncovered only weak and inconsistent epidemiological association between exposure to transmission line magnetic field and adverse health effects. So next is the reducing magnetic field from transmission lines. A common method to reduce magnetic field is to bring the lines closer together. The magnetic field interfere with one another, producing a lower field. The conductor can be brought closer together by using different types of structure or double circuiting two lines on the same structures. However, there are electrical safety limits to how close together conductors can be placed. Conductors must be far enough apart so that arcing cannot occur, that ensure that utility employees can safely work around them. Wooden transmission line can also reduce the generated magnetic field. The reduction occurs because the underground lines can be installed closer together than overhead lines. Overhead lines need to be further apart because air is used as an insulator, whereas underground cables use rubber, plastic, or oil for insulations. Third one is the endangered or threatened and protected species. Potential impact to protected species. Endangered species are species whose continued extinction is in jeopardy. Threatened species are likely to become endangered. Special concern species are those species about which some problem of abundance or distribution is suspected but not yet proved. The main purpose of special concern category is to focus attention on certain species before they become threatened or endangered. The WDNR Bureau of Endangered Resource (BR) manage the Natural Heritage Inventory (NHI) database, which lists current of and historical occurrence of rare plants, animals, and natural communities. The database includes the location and status of these resources. However, most areas of the state have not been surveyed extensively or recently, so the NHI database should not be relied upon as a sole information source for rare species. The mitigation of impacts to rare species and their habitats. Preliminary research and field assessment indicates that rare species or natural communities may be present in project area. The utility should conduct WDNR approved survey prior to construction. If a threatened and or endangered species is likely to be in the project area, impact can usually be avoided or minimized by modifying the route, changing design the transmission line, reducing the workspace at the particular location, employing special construction techniques use, or limiting construction activities to specific season. In some cases, transmission line rows can be managed to provide or improve habitat for some rare species or communities. For example, some rows are being actively managed to provide habitat for the Karna blue butterfly, a federally listed species. Next step is the implantable medical device and pacemakers. Potential impacts of the implantable medical device is the implantable medical devices are becoming increasingly common. Two such devices, pacemaker or implantable cardioverter defibrillators (ICDs), have been associated with problems arising from interference caused by EMF. This is called electromagnetic interference for EMI. EMI can cause inappropriate triggering of a device or inhibit the device from responding appropriately. ICD manufacturer recommended threshold or for modulated magnetic field is 1 Gauss. 1 Gauss is the 5 or 10 times greater than the magnetic field likely to be produced by the high voltage transmission line. Research show the wide range of response for the threshold at which ICDs and pacemaker responded to an external EMI source. Next is mitigation of EMI. Mitigation of EMI is the transmission line of only one of the number of external EMI sources. Exposure to magnetic field produced by the transmission line generally will not affect pacemaker or implantable defibrillators. All pacemaker and ICD patients are informed of potential problems associated with exposure to EMI and must adjust their behavior accordingly. Moving away from a source is the standard response to the effects of exposure of EMI. Patients often shield themselves from EMI with a car building or the enclosed cab of a truck. So the last one is the stray voltage. Concept of stray voltage is the stray voltage and its impact on livestock and other confined animals has been studied in detail by state and federal agencies, universities, electric utilities, and numerous scientists since the late of 1970s. The PSCW as open investigation encouraged the upgrade of rural distribution system, established measurement protocols, and compiled the stray voltage database to track investigation, all in order of develop successful strategies for minimizing stray voltage in farm operation. So next is the potential impact of the stray voltage. Health problem can be difficult to diagnose. There are many factors to consider such as health, environment, diet, and health. Daily cow behaviors that may indicate the presence of stray voltage include nervousness and milking time, increased milking time, decreased milk production, increased somatic cell count, increased defecation or urination during milking, hesitation in approaching waters of feeders, a reluctance to enter the barn or milking parlor, or an eagerness to leave the barns. In 1996, the PSW established the stray voltage level of concern of 2 milliamps. PSCW docket 05 E1115. The level of is not intended as a damage level, but as a very conservative below the injury level, below the point where moderate avoidance behavior is likely to occur, and well below the where a cow's behavior or milk production would be affected. Last one is the mitigation of the stray voltage. When stray voltage is a concern, LTM measurement is confined livestock areas should be done using established PSCW approved testing procedures with appropriate equipment. These testing protocols have been developed to collect a reasonable set of data useful in the analysis of the quantity of quality of the stray voltage that may be present under variety of conditions and the source of such stray voltage. Field research show the cow contact current is often dependent on both on and off farm electrical power systems. The common on farm source of stray voltage is the inappropriate interconnection of equipment grounding conductor with the neutral conductors of the farm wiring system. Mitigation of stray voltage can be achieved throughout a variety of proven and acceptable methods such as additional grounding or the installation of an equipotential plane. And that's all for it. Thank you very much. Thank you.